I am the virtual teacher at Egnatia Career College. Today we'll teach electrical outlets. This is video number 2. Electrical outlet. After studying this unit, you should be able to identify and explain the electrical outlet symbols used in the plans of the single-family dwelling. Discuss the types of outlets, boxes, fixtures, and switches used in the residence. Explain the methods of mounting the various electrical devices used in the residence. Understand the meaning of the terms receptacle outlet and lighting outlet. Understand the preferred way to position receptacles in wall boxes. Position wall boxes in relation to finished wall surfaces. Make surface extensions from concealed wiring. Determine the number of wires permitted in a given size box. Electrical outlets. The Canadian Electrical Code, CEC, defines an outlet as a point on a wiring system where current is taken to supply utilization equipment. The type and location of electrical outlets used for an installation are shown on electrical floor plans. A toggle switch is not an outlet. However, the term outlet is used broadly by electricians to include non-current consuming switches and similar control devices in a wiring system when estimating the cost of the installation. Each type of outlet is represented on the plans as a symbol. This figure shows the outlets by the symbol as a circle with 2 horizontal lines. The curved lines in the figure run from the outlet to the switch or switches that control the outlet. These lines are usually curved, so that they cannot be mistaken for hidden edge lines. Outlets shown on the plan without curved lines are independent and have no switch control. When preparing electrical plans, most architects, designers, and electrical engineers use symbols approved by the Standards Council of Canada, SCC, whenever possible. However, plans may contain symbols that are not found in these standards. A receptacle outlet is an outlet where one or more receptacles are installed. When a receptacle is connected to the wires, the outlet is called a receptacle outlet. For ease in working with wiring devices, CEC Rule 12-3006 requires that at least 150 mm of free conductor be provided. A lighting outlet is intended for the direct connection of a lamp holder, a lighting fixture, or a pendant cord terminating in a lamp holder. When a lighting fixture is connected to the wires, the outlet is called a lighting outlet. The CEC requires that at least 150 mm of free conductor be provided. When unlisted, non-standard symbols are used, the electrician must refer to a legend that interprets these symbols. The legend may be included on the plans or in the specifications. In many instances, a notation on the plan will clarify the meaning of the symbol. Although several symbols have the same shape, differences in the interior presentation plans indicate their different meanings. For example, different meanings are shown in this figure 3.5 for the outlet symbols. A good practice in studying symbols is to learn the basic forms first and then add the supplemental information to obtain different meanings. This figure shows symbols for different types of lighting outlets, like lamp holder with pull switch, recessed luminaire, surface-mounted luminaire, etc. This figure shows symbols for receptacle outlets, like single receptacle outlet, duplex receptacle outlet, triplex receptacle outlet, etc. This figure shows miscellaneous symbols, like alarm smoke, alarm heat, battery, buzzer, etc. Lighting fixtures and outlets. Architects often include in the specifications an amount of money to purchase electrical fixtures. The electrical contractor includes this amount in the bid, and the choice of fixtures is then left to the homeowner. If the owner selects fixtures whose total cost exceeds the fixture allowance, the owner is expected to pay the difference between the actual cost and the specification allowance. If the fixtures are not selected before the roughing-in stage of wiring of the house, the electrician usually installs outlet boxes having standard fixture mounting studs. Most modern surface mount lighting fixtures can be fastened to an octagon box or an outlet box with a plaster ring using appropriate #832 metal screws and mounting strap furnished with the fixture. When mounting an outlet box in a wall or ceiling that is to be insulated and covered with a vapor barrier, you must make special provision to maintain the integrity of the vapor barrier. A polyethylene boot covers the outlet box and is sealed to the 6 mm polyethylene vapor barrier. This figure shows a typical polyethylene boot installed on a 102 mm 4-inch octagon box. A box must be installed at each outlet or switch location, Rule 12, 3001. There are exceptions to this rule, but in general, they relate to special manufactured wiring systems where the box is an integral part of the system. For standard wiring methods, such as cable or conduit, a box is usually required. Figures illustrate types of non-metallic and metallic boxes. Outlet boxes must be accessible, Rule 12, 3014, 1. Be careful when roughing in boxes for fixtures, and also when hanging ceiling fixtures to non-metallic device boxes. Non-metallic device plaster rings. Metallic device boxes. Metallic device plaster rings. Any non-metallic box, unless specifically marked on the box, or carton for use as a fixture support, or to support other equipment, or to accommodate heat-producing equipment. Unless the box, device plaster ring, or carton is marked to indicate that it has been listed by the CSA for the support of fixtures. Do not use where fixtures are to be hung. Refer to Rule 12 to 1110. Be careful when installing a ceiling outlet box for the purpose of supporting a fan. See Unit 11 for a detailed discussion of paddle fans and their installation. These switch boxes are made of steel. If the owner selects fixtures before construction, the architect can specify these fixtures in the plans and/or specifications, giving the electrician advance information on any special framing, recessing, or mounting requirements. This information must be provided in the case of recessed fixtures, which require a specific wall or ceiling opening. Many types of lighting fixtures are available. This figure shows several typical lighting fixtures that may be found in a dwelling unit. It also shows the electrical symbols used on plans to designate these fixtures, and the type of outlet boxes or switch boxes on which the lighting fixtures can be mounted. A standard receptacle outlet is shown as well. Switches. This figure shows some of the standard symbols for various types of switches and typical connection diagrams. Any sectional switch box or 102 mm 4-inch square box with a side mounting bracket and raised switch cover can be used to install these switches. Junction boxes and switch device boxes, Rules 12 to 3000 through 12 to 3034. Junction boxes are sometimes placed in a circuit for convenience in joining two or more cables or conduits. All conductors entering a junction box are joined to other conductors entering the same box to form proper connections so that the circuit will operate in its intended manner. All electrical installations must conform to the CEC standards requiring that junction boxes be installed, so that the wiring contained in them shall be accessible without removing any part of the building. In house wiring, this requirement limits the use of junction boxes to unimproved basements, garages, and open attic spaces, because blank box covers exposed to view detract from the appearance of a room. Rule 12-3001 requires that a box or fitting be installed wherever splices, switches, outlets, junction points, or pull points are required. An outlet box such as the one installed for the front hall ceiling fixture is really a junction box because it contains splices. Removing the fixture makes the box accessible, thereby meeting CEC requirements. Sometimes a change is made from one wiring method to another. For example, armored cable to electrical metallic tubing, EMT. The fitting where the change is made must be accessible after installation. Boxes shall be rigidly and securely mounted. Rule 12-3010-1. Non-metallic outlet and device boxes. The CEC permits non-metallic outlet and device boxes to be installed where the wiring method is non-metallic sheath cable. Rule 12-524. Non-metallic boxes may be used with armored cable or metal raceways, but only if a proper means is provided. Inside the boxes to bond any and all metal raceways and/or armored cables together. Rule 12-3002. The house wiring system is usually formed by a number of specific circuits, each consisting of a continuous run of cable from outlet to outlet, or from box to box. The residence plans show many branch circuits for general lighting, appliances, electric heating, and other requirements. The specific CEC rules for each of these circuits are covered in later units. Ganged switch, device, boxes. A flush switch or receptacle outlet for residential use fits into a standard 3 by 2 times by 2.5 inch sectional switch box, sometimes called a device box. When 2 or more switches or outlets are located at the same point, single switch boxes may be ganged or fastened together to provide the required mounts. Or a welded, 2 or more, gang box may be used. 3 switch boxes can be ganged together by removing and discarding one side from both the first and third switch boxes, and both sides from the second, center, switch box. The boxes are then joined together. After the switches are installed, the gang is trimmed with a gang plate having the required number of switch handle or receptacle outlet openings. These plates are called 2 gang wall plates, 3 gang wall plates, and so on, depending on the number of openings. The dimensions of a standard sectional switch box, 3 by 2 inches, are the dimensions of the opening of the box. The depth of the box may vary from 1/2 inches to 3/2 inches, depending on the requirements of the building construction and the number of conductors and devices to be installed. Single gang device boxes are normally mounted to a structural member of the building with nails or screws. Gang sectional device boxes may be installed using a pair of metal or wood mounting strips. Boxes for conduit wiring. For some types of construction, conduit rather than cable wiring is used. When conduit is installed in a residence, it is quite common to use 102 mm square boxes trimmed with suitable plaster covers. There are sufficient knockouts in the top, bottom, sides, and back of the box to permit a number of conduits to run into it. Plenty of room is available for the conductors and wiring devices. Note how easily these 102 mm square outlet boxes can be mounted back to back by installing a small fitting between them. You can trim 4-inch square outlet boxes with 1 gang or 2 gang plaster rings where wiring devices will be installed. Where lighting fixtures will be installed, use a plaster ring having a round opening. Any unused openings in outlet and device boxes must be closed, using knockout fillers. Special purpose outlets. Special purpose outlets are normally shown on floor plans. They are described by a notation and are also detailed in the specifications. The plans included with this textbook indicate special purpose outlets by a triangle inside a circle with a subscript letter. In some cases, a subscript number is added to the letter. When a special purpose outlet is indicated on the plans or in the specifications, the electrician must check for special requirements, such as a separate circuit, a special 240-volt circuit, a special grounding, or polarized receptacle, a device box with extra support or other preparation. Special purpose outlets include central vacuum receptacle, weatherproof receptacle, dedicated receptacle, perhaps for a home computer, air conditioning receptacle, clock receptacle. Number of conductors in a box. Rule 12 to 3034 dictates that outlet boxes, switch boxes, and device boxes be large enough to provide ample room for the wires without having to jam or crowd the wires into them. CEC Table 23 specifies the maximum number of conductors allowed in standard outlet boxes and switch boxes. A conductor running through the box is counted as one conductor. Each conductor originating outside the box and terminating inside it is counted as one conductor. Conductors that originate and terminate within the box are not counted. When conductors are the same size, the proper box size can be selected by referring to CEC Table 23. When conductors of different sizes are used, refer to CEC Table 22. Tables 22 and 23 do not consider fittings or devices such as fixture studs, wire connectors, hickeys, switches, or receptacles that may be in the box. For assistance in this case, see Table 3.3. When the box contains one or more fittings, such as fixture studs or hickeys, the number of conductors must be one fewer than shown in the table for each type of device. Deduct 2 conductors for each device mounted on a single strap, switches, receptacles. The deduction of 2 conductors has become necessary because of severe crowding of conductors in the box when the switch or receptacle is mounted or when dimmer switches are installed. In most cases, dimmer switches are larger than conventional switches. Deduct 1 conductor for every 2 wire connectors. For example, for 2 or 3 wire connectors, deduct 1 wire, for 4 or 5 connectors. Figure shows how transformer leads number 18. Bonding conductor AWG or larger are treated when selecting a box. Wire number 16 or number 18 AWG supplying a lighting fixture is not counted when sizing the box that the fixture is mounted on. This is stated in Rule 12, 3034, 1d. Box fill. The following method can make box fill easier to calculate when determining the proper size of junction box or wall box to install. 1. Count the number of circuit wires. 2. Add 1 wire for a fixture stud, if any. 3. Add 1 wire for each pair of wire connectors. 4. Add 1 wire for 1 or more isolated, insulated, grounding conductors, if any. 5. Add 2 wires for each wiring device. Positioning receptacles. Although no actual CEC rules exist on positioning receptacles, there is a concern in the electrical industry that a metal wall plate could come loose and fall downward onto the blades of an attachment plug cap that is loosely plugged into the receptacle, thereby creating a potential shock and fire hazard. Therefore, when metal wall plates are used, position the grounding hole to the top. A loose metal plate could fall onto the grounding blade of the attachment plug cap, but no hazard would result. When metal cover plates are used for horizontal receptacles, position grounded neutral blades on top. A loose metal plate could fall onto these grounded neutral blades with no hazardous effect. To ensure uniform installation and safety, and in accordance with long-established custom, standard electrical outlets are located, as shown in this figure. These dimensions usually are satisfactory. However, the electrician must check the blueprints, specifications, and details for measurements that may affect the location of a particular outlet or switch. The cabinet spacing, available space between the countertop and cabinet, and the tile height may influence the location of the outlet or switch. For example, if the top of the wall tile is exactly 1.22 meter, 48 inch, from the finished floor line, a wall switch should not be mounted 1.22 meter, 48 inch, to center. This is considered poor workmanship since it prevents the wall plate from sitting flat against the wall. The switch should be located entirely within the tile area or entirely out of the tile area. This situation requires the full cooperation of all trades involved on the construction job and a careful review of the architectural drawings before roughing in the outlets. See the figure for how to locate switches next to a doorway. Where doorways are framed with a single stud, install blocking as shown before mounting switch boxes. This will ensure that the switch does not interfere with the door trim. Faceplates. Faceplates for switches and receptacles shall be installed to completely cover the wall opening and seat against the mounting surface. The mounting surface may be the wall or the gasket of a weatherproof box. The installation is to align the slots in all the faceplate mounting screws in the same direction. Bonding. Bonding is the joining together of all the non-current carrying metal parts of an electrical system with a conductor that has a low impedance, opposition to the flow of current. Bonding provides protection from shock hazards by maintaining all of the non-current metal parts of the electrical system at the same potential voltage. It prevents a voltage from developing between the enclosures of two pieces of electrical equipment due to static buildup or the failure of insulation on conductors. Bonding is the most important part of the installation of electrical outlets. It will permit the system to fail safe. Your electrical inspector will look closely at the workmanship involved in the installation of the bonding conductors. It is important that the continuity of the bonding conductor be maintained. Therefore, the bonding conductor is brought into the box and attached to the bonding screw in the box before it is attached to the green bonding screw on a receptacle. With such connections, if someone cut the connections to the receptacle to remove it, it would not interfere with the bonding connection to the box. When connecting the bonding conductor to the bonding screws in outlet boxes, ensure that the conductor does not get pinched between the head of the screw and the shoulder of the box, which prevents the conductor from slipping out from under the head of the screw as the screw is tightened down. This can damage the bonding conductor, which reduces its size, cross-sectional area, and its effectiveness.